right, this is a question, or a few questions, 3 questions from 1.3 Practice B. You will be required on your next test to evaluate a function at a specific value. The important thing to remember is that we've been working with function notation. In function notation, an ordered pair, instead of looking like x comma y, it looks like this, f of x equals y. In number 9, n of -4 means that they've given you an x value. Notice that x is always related to domain. In piecewise functions, the domain is always given after the comma, the domain of each function. So what you need to do is you need to ask yourself, for the function n of x, where am I going to substitute the -4? What domain does this fall under? Does it fall under the first piece, which is a constant function? Does it fall under the square root function domain? Or does it fall under the quadratic domain? One thing that might help you in these problems is to draw a quick number line, putting 0 in the middle. Plot the limits that they gave you for the domain. So there's a -1 and a +3. Then ask yourself, okay, the domain value that they gave me, where is it on the number line? So -4 is to the left of -1. So that means that it belongs to the constant function, since the domain for constant function is any number x that's less than -1. -4 is less than -1. So I'm going to substitute that -4 into the piece that has the constant. Okay, so I substitute the -4 into it, and since that's the only place I can substitute the x value, and there's no x's, notice there are no x's in a constant function, that's your answer. -1, look at your number line. Notice that it also appears on both the constant function and the square root function. But in the constant function, I only want numbers less than -1, not less than or equal to -1. In the square root function, I want numbers greater than -1 and greater than or equal to -1 and less than or equal to 3. So since this includes the -1, that's the function I'm going to substitute into. So I'm going to copy the square root function because -1 is within that domain. And I'm going to substitute it into both places where the x exists. Remember that in the constant function, I can only substitute it on the left side, not the right. Here you can substitute the -1. So here, again, in the constant, there was only one place where I can substitute. Here, I can substitute it into 2 different spots. Then I simplify using the order of operations. So do what's inside the grouping symbol first. 3 minus -1 is 4. There's like a -1 multiplied in front. So when you take the square root of 4, you get 2. But because of the negative out in front, you get -2. So n of -1 equals -2. Okay, now 4.5 is, and so think of the number line, is between 4 and 5, right? 4.5. That value is greater than 3. So that means that I'm going to substitute this into the quadratic function because the quadratic function had a domain of all x's greater than 3. And remember, 4.5 is greater than 3. So I'm going to copy the quadratic. You should be doing this without a calculator. I'm going to substitute my value into both places where I saw the x. So the x appeared on the left and the right. I'm going to substitute the 4.5. And then I'm going to use order of operations to simplify. Order of operations says to simplify what's inside a grouping symbol first. So 4.5 minus 4 is just a half. Then I need to multiply 0.5 times 0.5. 5 times 5 is 25. Carry the 2. 5 times 0 is 0 plus 2 is 2. If you multiply the next row, I don't know if you remember this rule, so if you multiply, so I multiplied this 5 times 5 and times 0, then I have to multiply the 0 times 5 and 0, but that will all be zeros. When you're multiplying decimals, you got to ask yourself how many numbers were behind the decimal in the original problem. So 2 of them. So your answer should have 2 numbers behind the decimal. So that answer is 0.25. So 0.5 squared is 0.25. So negative 0.25 plus 1. Think like money. What's $1 minus 25 cents? 75 cents. And that's your answer for n of 4.5.